that is 110. If this sequence is detected, then only uh, we will get high output signal. Otherwise, output signal will be low signal. So that we have discussed yesterday. Now, in continuation with that, okay, actually I have shown you output waveforms whenever we have certain inputs given to that. Okay, so let us again check for that. Open that program. So, this is the VHDL code for the Murray machine sequence detection for 110. So already we have discussed this, so I will not spend time on that, but just we will see once again how we were getting the output waveforms when we simulate this. Okay, so let's just directly simulate this. Okay, already we have checked syntax, so behavioral check syntax step that we have already done. So I will just go to simulate behavioral model. So here you will find that whenever clock is high and if the input is high in the sequence of 110, then only you will get high output signal. So here though for this clock signal output is high, but after that there is a low signal. So input is high, sorry, input is high, but after that it is going low, so output is not high. Okay, but for this clock signal input is high, then again here it is going high, and after that for this clock signal it, it is a low. So you are getting the sequence of 110. So here you will find that at this rising edge of the clock output is going high. Okay, and it will remain high for one clock cycle and again it is going low. Okay, so this is the sequence detector for 110 sequence. Okay, but here whatever code we have written for that, you can find that here this orange section you will find. Okay, so that means output is here. If I click here, you will find that this W, that is the output, is U. Okay, so it has the value that is a U. Okay, actually we considered the real logic as a 0 or high. Okay, so that means it may be at a high logic level or low logic level, but there in a VHDL there are, other than this two logic levels, there are certain other logic levels, and one of them is a U. Okay, so U means it is a uninitialized, or we can say it as an unknown value for the output. Okay, so we cannot predict what will be the value of this high output signal. Okay, so our this output signal, so here you will find that this is a, in a orange color. If you zoom this, then you can find it that it is of a orange color. Okay, and it is not at a actual logic level 0, or it is not at high logic level. Okay, it is in between somewhere. Okay, म्हणजे जे काही व्होल्टेज आहे ते कुठलं तरी वेगळंच व्होल्टेज आहे, आणि ते तुम्हाला 0 पण नाही मिळते आणि 1 पण नाही मिळते. आता हे का मिळतंय असं? कारण जर तुम्ही तुमचा आपला प्रोग्राम बघितला तर आपण इथे काय केलं, याच्यामध्ये हा टेस्ट बेंच आहे. ओके, सो फर्स्ट ऑफ ऑल आय विल शो यू प्रोग्राम. ओके, we have used two inputs. Okay, that is the clock and input signal. Okay, these are the two input ports and W is the output port. Okay, and with respect to clock signal we are checking what is the input, and depending on that it is changing its state. Okay, so for this, in a test bench what we have done, we have initialized input X initially value for the clock that we have set as a 0, and X is also set as a 0, but we have not set any value for X. We sorry, any value for the output. We have just considered that it will be a signal which is having the logic type, that is a std underscore logic, but there we have not mentioned what will be the initial value. Okay, so in that case again we have not defined what should be the value, output value, or whether we are going to reset that signal or not. Okay. So what is required, that means suppose in a earlier case it is the one value. So whether we are going to make it as a 0 or 1, that we have not discussed in this program. So whenever we are designing any application, that time as a good designer, it is important that each and every input signal as output signal, it must be at a fixed logic level. Okay. And so to make that, we can have certain another signal that can be added in this application. And so we can have this output at a fixed logic level. And so for that, I have one more program for this. So I'll open that program now. So this is the new program. Now here, as usual, the first step, there is the library declaration, and after that there is an entity declaration. Okay. Now here in this entity, now you can see there is a slight change in this entity, that I have added one more signal in this. Okay. जर तुम्ही नीट बघितलं तर तुमच्या लक्षात येईल की म्हणजे clock आणि x. Okay, these are the input signals that I have added. Then W, that is the output signal, that is also present. But beside these three ports, I have one more port that is added, and that is a reset. Okay, so which is an input port. Okay, of the type standard logic. Okay, so now what this will do, as here you can reset your circuitry. Okay, so depending on the high signal at reset, you can make W that is equal to 0, and then you can start your application with keeping this reset signal at a 0 logic level. Okay, so if 0 is present at reset, then only circuit will work, okay, in the proper sequence. Otherwise, if reset is high, then output will remain as a 0. Okay, so for that, the program that will be now little bit changed there, that first of all, in our architecture body, we are again going to have a process which is going to simulate all the statements in a sequential manner. Okay, and then here we have, as we have added here reset signal, so we will have the instruction that is a if reset is equal to 1, then output will be equal to 0. Okay, and if it is, this condition is false, that means now if reset is equal to 0, then we are going to check for the whether clock is equal to 1 or 0. If clock is equal to 1, then all the other instructions that we have discussed earlier, that will be executed sequential manner, and then we will get output. Okay, so depending on whatever is the input sequence present. Okay, so now let us simulate this program. So I'll just open a test bench for this. Okay, so this is the test bench. Now here you can see that for initial values of clock, it is equal to 0, initial value of the input signal x, that is a 0, and reset that I have set to 1. That means now with these values, W, that is the output, that will be equal to 0. Okay, are you getting this point? So what will happen now? Whenever we are going to simulate this program, that time initial value of W will be now fixed, and it will be having logic level that is equal to 0. Now it will not be at a 0 value, but it will be at a 0 and it will not be at a u value, that is an uninitialized value, but it will be at a 0 value. Okay. So clock period that we are going to consider as a 10 nanosecond, which is the default value. Actually, you can change it if you want, but I have not changed it. Then we have one process, as we discussed in earlier session, that for a clock period. Okay, so that means we are going to have this, as we have clock period that is equal to 10 nanoseconds. So we are going to now define on time and off time of that clock. Okay, so we are having here 50% duty cycle. Okay, so this default program that or default process definition that you will get. Okay, if you want to change this period, that also you can do, but again it is better to keep on time and off time that are equal. That means 50% duty cycle, that is okay. Okay, so here clock that is equal to 0 for the period of clock period divided by 2, that means for 5 nanosecond, and it will be equal to 1 for again next 5 nanosecond. Okay, so this is the clock process, and after that we have a stimulus process. Okay, so that means we are adding certain uh, input stimulus to the circuit. Okay, so here now initially we have set reset signal that is equal to 1. Okay, so because of that we will get output that is equal to 0. Now what we are going to do, we are going to reset this reset signal as equal to 0, and that means now it will proceed, that program will proceed next execution, and then depending on values of x it will enter in the next steps. Okay, so initially I have put x is equal to 0 for 10 nanosecond, next 10 nanosecond it will wait for 10 nanosecond, that means reset cycle that will be for 10 nanosecond. After that okay, I'll delete this instruction because this is not of use. Okay, then reset that is 0 for 10 nanosecond, x is equal to 0 for 10 nanosecond. Okay, after that we have changed value of x to 1 for next 25 nanosecond. Okay, then again it is changed to 0 for 25 nanosecond. Now once we have changed value of reset signal to 0, there is no need to change it again. Okay, so we are going to keep this value as a 0 only. Okay, we are not going to change this signal, because if we make it 0, all the values that will get resetted, and so we are not going to do this. So next, we are going to keep this 0 value for 25 nanosecond and 1 for 10 nanosecond. Okay, you can change this sequence as if you want. So this is the stimulus that we have added here, and then depending on these inputs, we are going to check what will be uh, output. Okay, so let us first check behavior. I have changed, not saved, so I will save first and then behavioral check syntax. Okay, so you can see here it is completed successfully. So now let us simulate this. Okay. Here you can see that the simulation is running. So let us wait. Okay, so it is completed, and now you can see these waveforms. Okay, I will just zoom it. Okay. So now here you can find that for the first 10 nanosecond as input x is equal to 0, clock signal that is 0 for 5 nanosecond here, sorry 10 nanosecond, and it is 0 and then it is changing. So because we have the clock period that is of 10 nanosecond, and initially we have made this clock signal that is 0. So 5 for 5 nanosecond it will remain 0. X will be remaining 0 for 10 nanosecond first, and after that again we have made it 0 for next 10 nanosecond. So it is remaining 0 for 20 nanosecond totally. And reset signal, it is initially at high logic level, that is a 1 for first 10 nanosecond. Okay, so here you can see on this, for the first 10 nanosecond we have this reset signal, that is a 1. Okay, after that we have made it 0, and we are continuously keeping it at a 0 logic level. So here you can find that this is next, after that it is continuously at a 0 logic level. And so here as reset is high, so that time W, that is the output signal, is at a 0 logic level. Now here that means the output signal has particular fixed value. Okay, so it is not u value, but it is a certain fixed value, and that is very important whenever you are designing any application, that your all signals that must be having certain fixed value. Okay, and so that you must have observed in most of the ICs you will get this reset signal, so that we are getting output signal at particular fixed value. Okay, then after that, as per our test bench, we have made this signal high, X signal high at a 20 nanosecond. So it is high. So for the first, after that, whatever is the rising edge of the clock and clock is becoming high. So at that time, it will be counted as a 1, and so it is going to enter in the next state. That sequence detector will enter into the next state, and so next, in the next state also there is a high signal, so your count is 1 1, and after that here at this next clock cycle, input is going low, so the sequence, that is a 110 that you are observing here, we are getting that sequence, and therefore output is high at this. Okay, after that, for the next clock cycle, input is 0, so output will go 0, and now here it is going high. Okay, so for the next clock cycle it will consider 1, but then again it is going low, so it will go for again next clock cycle. So here you will find that for here it is a high signal 1 1, and at this clock signal it is a low, so 110, so here it is going high. Okay, so this is a sequence detector for 110. Okay, so as this is the state machine, the Mooring machine for this 110 signal. Okay, so now let us have one more example of this Moore machine state diagram. So now this is for you. Okay, just draw a state diagram for the sequence 1101. Okay, actually this was your homework, but only one student has sent me that. Okay, so now right now you draw this diagram, state diagram, for using Moore machine for the sequence 1101. Okay, take 5 to 6 minutes to complete this, and then we will proceed for this. Okay, so complete this. Now here, this is a Moore machine, and we are going to now detect sequence of 4 bits. So you will require here 5 states. Okay, now this is a hint to you. So using these 5 states, draw a sequence detector. Once you finish, just unmute yourself, and also you can make your video on and show your diagram to me. Prajakta, you wait for some time, don't show it immediately. Okay?
Yes, ma'am.
Anyone has doubt? Is it possible for all to draw state machine diagram? Payal?
Yes, ma'am. No doubt.
ओके. जमणार आहे ना करायला?
हो मॅम.
हा, चला काढा. सगळेजण काढा. आणि मग तुमचा व्हिडिओ ऑन करा आणि दाखवा. प्रेझेंट करा ते. सत्यजित? सत्यजित मुळे? हॅलो सत्यजित, आर यू देअर? If anyone has doubt, they can ask. You have to draw a diagram, state machine diagram for the sequence detector 1101. So we are going to detect 4 bits and we are using Moore machine So that means we will require 5 steps. Okay. Once you finish your diagram, just make your video on and show it or present it. Prathamesh, have you finished?
No, ma'am.
Uh, so anyone has finished? Completed? Deepali?
Yes, madam.
Okay. Have you completed?
थोडं राहिले मॅम.
Okay, ठीक आहे. Complete करा. प्रतीक्षा प्रतीक्षा पाटील
येस मॅम.
झालं काढून.
मॅम थोडं राहिले 2 मिनिट.
Okay, I hope you have completed now. So who is going to present now? Okay. So Prajakta,
Yes ma'am.
yes, present your diagram. Is it visible for all?
No ma'am.
Okay. I think it's blur. Okay. Okay. So will you explain this?
Yes
Okay.
ma'am.
I'll make here and you. Okay. So this is the first initial state. Okay. Now tell me what will happen next.
Ma'am, if one is get, then it go to the next state, that is B.
Yes. If that is a B. So if we have received 1, it will go to the next state. If it receives 0,
Then it remain in the same state, that is state A.
state A. After that,
After that, in state second, if one is get, then it go to the next state.
okay,
And if
then
0 is get, then it get back to the state A. After that,
next,
in state C, if 0 is get, it go into the next state, that is state D. And if 1 is get, it remain into the same state. After that, if 1 is get, then it go to the next state, E of 1. And if
okay. So the output will go now to the high
final state.
logic level. Okay, yes.
Yes, ma'am. in D state, if 0 is get, then it go to the initial state.
Initial. Yes.
If 1 is get at the state of E, if 1 is get, then it go to the state C. And if
Let's see.
0 is get, 0 is get, then it go to the state D.
D, or it will go
Yes,
to the initial state.
initial state.
It will go to the initial state, that is a A. Okay, because now what will happen here actually? My screen is visible. Okay, so
Yes, ma'am.
here for the first one, you will get here the sequence of 1. Okay, in the next clock cycle, here if you are getting 1 as an input, so it will be the sequence 1 1, and for the next again, if you are getting input as a 0, then the sequence will be that you are going to receive, that is a 1 1 0, and if you are getting again the next 1, then it will be the sequence 1 1 0 1. Okay, so the output will be now 1. Okay, when in a consecutive clock cycles you are getting 1101, then or you are receiving 1101, only then you are getting a that output signal that is equal to 1. But if in the first state itself you are getting 0, then it will remain in the same state. Okay, it will go to the next
Ma'am,
state only you are if you are receiving 1. Okay, now in the next
excuse me,
state
ma'am.
if you are receiving again 1, then it will go to the next state, that means sequence will be 1 1. But if you are receiving 0, then actually you are getting the sequence as a 1 0. So your sequence will break and it will return to the initial state itself. Okay, now again whenever it is reaching in the second state, that means in a state C, if you are receiving 0, then it will have, you will get a sequence that is a 110. So it will go to the next state. But if you are receiving 1, that means you are receiving a sequence that is of 111, and that is why as the sequence is not break, you are actually getting here 1 1 as a sequence. So that here it will remain in the same state, that is a C. Now once you reach to the state D, that time if you are receiving D as once, then it will go to the next state, that is a E, and the sequence that is a 1101, and then if you are receiving 0, that means you are getting a sequence of a 1100. As the sequence is break, therefore it will return to the initial state. And in this last state, suppose if you are receiving 1, okay, that means the sequence will be 11011. So now from here, that is a 111 that you can continue. So it will return to, because here you are getting a sequence of a 1 1 0 1 1. So from this sequence you can continue, that is a 1 1. So it will return to the state C. Okay, but if you are receiving 0, that means you are receiving a sequence 1 1 0 1 0, that means your sequence is broke here. So it will return to the initial state, that is a state A. So this is the sequence detector.
Ma'am,
Yes,
110, 11010. मॅम हे
yes,
सिक्वेन्स आपल्याला वरती पण
11010.
आपण 3 हे घ्यायचं का, कारण आपल्याला 0 आणि 1 हा सिक्वेन्स मिळालेला आहे.
1 0 मिळाला, पण आपला सिक्वेन्स आपल्याला काय पाहिजे, 1101. हा सिक्वेन्स हवा आहे आपल्याला.
नाही मॅम, शेवटच्या स्टेटमध्ये मॅम, फायनल
इथे
स्टेटमध्ये
ना इकडे
वन. हां मॅम, तो तो तेच.
हा एक मिनिट, तुम्हाला सिक्वेन्स काय मिळणार आहे? 1 1 0 1 0, बरोबर आहे.
हां
आता
मॅम.
तुम्ही समजा माझा इथेपर्यंत सिक्वेन्स मिळून गेला, पण मला पुढच्या सिक्वेन्स साठी जायचंय, तर मला कसं मिळालं पाहिजे? 1 1 0 1 अशा सिक्वेन्स मध्ये जायला पाहिजे. म्हणजे मला इथले लास्ट 2 बिट्स ऍटलीस्ट 1 1 मिळायला पाहिजे होतं, पण मला
येस
मिळतंय
मॅम.
काय? 1 0 मिळतं. मी जर त्याच्या आधी गेले तर इथं पण 1 0 मिळतं. म्हणजे माझा सिक्वेन्स कम्प्लीट होतो का? इथे कुठे होणार आहे का? पॉसिबिलिटी आहे का? नाहीये.
नाही.
म्हणजे इथे 0 आल्यामुळे माझा सिक्वेन्स ब्रेक झाला मध्येच. म्हणून मी कुठे जाणार आहे? इनिशियल स्टेटला जाणार आहे. याच्या इथे जर सपोज इथे 1 1 आलं, बरोबर आहे ना, म्हणजे जेव्हा 1 मिळतं इथे 1 1 आलं, पण मग 1 1 पासून पुढे मी कंटिन्यू करू शकते. म्हणून मी कुठे जाणार आहे? सी स्टेटला जाणार. लक्षात येतंय तुमच्या?
येस मॅम.
ओके. आता याच्या इथे इथे जर तुम्ही बघितलं, इथे मला सिक्वेन्स काय मिळाला असता? 1 1 0 0 मिळाला असता, बरोबर आहे ना. म्हणजे या कंडिशनला डी मध्ये जर मला 0 मिळतो, तर मला 1 1 0 0 मिळतो. ओके. आणि म्हणूनच माझा सिक्वेन्स ब्रेक होतो, आणि म्हणून मी इनिशियल स्टेटला जाते. ओके. सो दिस इज द sequence detector for 1 1 0 1. Okay. So now let us see program for this. So now I have already used this reset signal here. So library declaration and entity declaration part, that will be as usual. Okay. Then next is the architecture part, and in the architecture I am going to have a process which will have a sensitivity parameter, that is a clock. Okay. So then again one variable that I am declaring here, that is a state which is having a which is of a 3 bit, that is a, it is a logic vector 3 down to 0, that means 0 0 0. Okay. So now what we are going to do? We are going to first of all check what is the logic level at a reset signal. Okay. If it is equal to 1, then we are going to make output signal as equal to 0. And if it is not equal to 1, that means if it is equal to 1, then we are going to proceed next. Okay. So then we are going to again check for the clock signal. If it is 1, then we are going to check what is the state level value. Okay. So we are going to check state. Okay. And for that we are going to use a case syntax. Okay. So initially when 0 0 0, that means a state is there. If you are getting x is equal to 0, then state will be same state. Same state will be there. So it will be in a 0th, 8th state one. Okay. If it is equal to 1, then state now next state, that will be 0 0 1. Okay. And output signal, that will be equal to 0. Okay. Now if okay, I have to make this as a W that should be assigned to 0. Now okay, so now when state is 0 0 1. Okay. So when it is in a bit state, if x is equal to 1, it will go to the next state, that is a 0 1 0, and output will be equal to 0. Otherwise it will go to the eighth state. That means it will be in a state 0, 0, 0. Okay. Then W, that will be W will be equal to 0, and if else it will go to the zeroth state. Okay, so that means initial state. Now whenever it is in a seed state, that means 0, 1, 0, if x is equal to 1, then it will go, or it will remain in the same state, that is 0, 1, 0 C state, and output is equal to 0, else it will go to the next state, that is a 0, 1, 1. Okay, and W, that will be equal to 0. Now when it is in a D state, that is a 0, 1, 1, if you receive x equal to 1, then state next it will go into the next state, that is a 1, 0, 0, and W, that will be equal to 1. Okay, now here W will become as a 1, else it will go to the state 0, 0, 0, and W will be equal to 0. Okay, now here actually we used 3-bit variable for a state. Okay, so we will have certain next state, that is a 1, 0, 0, then 1, 0, 1. Okay, and all, but we are interested in a 1, 0, 1 only. So for that, what we are going to state, when other condition will be there, that means when other cases for state will be there, we are going to keep x is equal to 0. If we are receiving x is equal to 0, then it will go to the state 0, and W will be equal to 0, else state will be equal to 0, 1, 0, and W will be equal to again 0. Okay, so then end of this if statements, all ifs, and end of the case statement and process that we are doing, and this is the architecture of this sequence detector 1101. Okay, now let us simulate this program. Okay, before that, as I have changed certain, so I will check syntax for that. Okay, I will just show you RTL schematic for this also. So this is the RTL schematic where you are getting this diagram. So once you double click on that, you can see a complete diagram. Okay, so this is the complete schematic for this. Okay, now let us go for the simulation. So okay, I'll just open this. So as earlier we have said, W is equal to clock is equal to 0 for initial value, then x is equal to 0, and reset is equal to 1. That means we are resetting this circuitry, and then we have made stimulus like for the first 22 nanosecond I am making x is equal to 1. Okay, already I have resetted made reset equal to 0, then x is equal to 1 for 22 nanosecond. Okay, you can have this any time period. Okay, then x is equal to 0 for next 10 nanosecond, once again x is equal to 1 for 10 nanosecond, again it is equal to 0 for next 10 nanosecond, and so on. Okay, so that I have done. Okay, and then let us simulate this. Okay. So here we will observe that whenever uh, For the first 10 nanosecond, reset is equal to 1. So W will be equal to 0, whatever may be the other values. But W that is equal to 0. Now we have made reset that is equal to 1. So depending on the clock and the input signal, there will be change at the output. So initially now here you can see that clock is 1 and X is equal to 1. So W is equal to 0, you can see here. Okay. Then for the next clock, again you are getting clock is 1, X is equal to 1, W is equal to 0. Okay. So we have received till now a sequence of 1, 1. Then after that, here you can see clock is 1, X is equal to 0 and W is equal to 0. Okay. So that means you have received again a sequence that is a 1 1 0. Okay. And after that, this clock cycle, you can see you have clock is equal to 1, X is equal to 1. So here you have received a sequence of 1 1 0 1, and that is why here you will find that W that is equal to 0. Sorry, 1. Okay. So that means you have received a sequence of 1 1 0 1, and that is why W is going to be 1. Okay. So similarly here also you can see here it is a 1 1, okay, 1, then 0, and here it is becoming 1. So you are getting output that is equal to 1. Okay. So thus we have got a sequence of 1 1 0 1. Okay. So this is the one method, okay, to have the state. Okay. Another method for defining state is, for that I will show you one more program. Actually, I should close this, and then I will open from this. Now this is a one. I hope. Okay. This is similar to the earlier one. Okay, I just need a change there. Okay. So now मगाच्या प्रोग्राम मध्ये आपण काय केलं होतं की स्टेट आपण प्रोसेस मध्ये डिफाईन केलं होतं म्हणजे डिक्लेअर केली होती. ओके. आणि त्याच्यासाठी आपण ऍज अ व्हेरिएबल म्हणून कन्सिडर केलं होतं. Instead of that, we can have a type. Okay. And here I have defined states. Okay. So I have defined 5 states: A, B, C, D, E. Okay. And then I have used a signal state for which we assign to the state. Okay. And initial value of state that I have considered as a. And then in the similar way, I have returned the program. Okay. But now, in an earlier state, what we used a variable. State that is used as a variable. Now here, I have used state as a signal, and that is why assignment operator that I am going to use for this is a less than equal. Okay. But other way, and also I have not used here numbers. Okay. So that means 1 or 0, that is not used, but there is a later, and that is why there is no need to use a quote. Okay. So in that way, I have written this program. Okay. So I will share this with you. Just go through this, and then if you have any doubt, you can ask me. Okay. So I will just simulate this.
Okay,
Okay. I will just share this. Simulate. Okay. So similar type of output that you will get. Okay. The test bench is same, so you will get here similar output. Okay. So here you can see 1101, wherever you are getting 1101 sequence, after that output is high. Okay, so in that way we have done this. Okay, so there are two methods to have this state definition. Okay, so state declaration in this machine. Okay, so this is all about Moore machine sequence detector. Okay, so in the next session we are going to discuss about Mealy machine. Okay, so for today we will stop here. If you have any doubt, you can ask about this. Okay, you can have more practice to draw this so that it will be easier for you to understand how this works. Okay, so you can go for the another sequence, that is a 1011. Okay, and you can try for it this state machine. Okay, so for today we will stop here. You can leave this meeting. Thank you.